Okay, so today we're going to graph sine and cosine. So there's easy way of graphing that. We're going to look at sine and cosine. Last week we found out that sine and cosine are periodic, and it repeats after every 2 pi. Now, when we graph it, and we're going to see this pattern, every 2 pi will become same graph. So let's look at the sine graph. Y equal sine of x. Let me do that. Let me do it this way. All right, let's graph from 0, 1, 2, 3, 4, 5, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Let's make this 2 pi, okay? And then half of 2 pi would be pi. 1, 2, 3, 4, 5, 6, 7, 8. That's pi. And then half of 2 pi would be pi over 2. And then half of pi to 2 pi would be 1, 2, 3, 4. 2 pi, 3 pi over 2. Let's look at this. Do you guys remember the 0, then pi over 6, pi over 4, pi over 3, and pi over 2 for sine? And we had, what is it? We had 0, 1 half, square root of 2 over 2, square root of 3 over 2, and then we had 1. Okay? What I'm going to do is I'm going to put them in a decimal points, right? So this is 0, this is 0.5, square root of 2 over 2 would be, let me make sure, 2. 0.71, square root of 3 would be 0.87, and then we get 1. So let me plug this into that. 1, 2, 3, 4, 5. Let's make this 1, 2, 3, 4, 5. That's negative 1. At 0, you get 0. Where would the pi over 6? Given pi over 2 is over here, pi over 4 would be right over here. Let's go. That's pi over 4. Pi over 6, roughly somewhere over here, and pi over and then pi over 6 would be somewhere roughly over here. Pi over 3 would be somewhere over here. That's pi over 6, pi over 3. Roughly, we don't have to be exact. So if I'm graphing it, at pi over 3 it becomes 1. Pi over 4 becomes a half. 1, 2, 3. It's right over here. Oh, sorry. Pi over 6 is that. Pi over 4 is 0.7. Somewhere over here. Then you get somewhere over here. If I'm connecting it, I get this. Now, as you have noticed last week, when we were getting the points on the second quadrant for sine, this is the second quadrant, which is from pi over 2 to pi. In terms of graphing, look at that. This is essentially the second quadrant. And what happens on the second quadrant? It gets the same number, but it slowly goes down. And then it repeats it again right over here. gets that right over here, and it gets back up again. And if you continue this graph, guess what? You get the same graph over here again. Let me erase all this useless information. And same also over here. Oh, this should have been. So right away, you see that this is from 2 pi to 4 pi, and you get the same graph over and over again. So it oscillates. That's what sine is. What about for cosine? Let's use the same, but we're going to use a different color. Oops, sorry. Let's use different color. For cosine. Cosine, you get what? 0, square root of 3 over 2, square root of 2 over 2. No, you get 1. Then you get 1/2, and then 0. So in terms of it, you get 0.87, 0.71, 0.5, and then 0. So if you're drawing it for cosine, y equal cosine of x, you start over here, and then you go right over here, right over there, right over there, right there. I'm gonna do it a little bit better. And that's your y equal cosine of x. So let me summarize it to graph it. To graph y equal cosine of x, all you need, starting the endpoint, and right now, I don't need to have this rule there. So all I need, starting the endpoint, the midpoint, the quarter points, the maximum, which is going to be 1, minimum is going to be -1. All I have to do is start at the top. That's the first one. Second one, it hits the middle. The third one, it goes bottom. Fourth one, it goes to 0, and then it goes back up top again. As for cosine, as for sine, starts at 0, then goes to the top, bottom, let me do it better. If you look at it very carefully, sine and cosine are essentially the same. It just moves over by pi over 2. And we're going to talk about those shifts later on. So let me give you the general term, how what it looks like. So if I give you something like y equal a sine of omega x, or y equal a cosine of omega x. So if you get in this type of information, what it tells you that A is the amplitude, absolute value of A is the amplitude. That means min or max. That's the highest it could be. And period is going to be, which is known as T, is 2 pi over omega. This omega we're looking at. So, given this information, let's graph y equal 2 cosine of x. It's very simple. Right over here it tells us what? Period equals 2 pi over, what's the omega? Omega is 1, right over here. So period stays 1. Whatever the amplitude, which is 2. So if I'm graphing that, I go from 0 to 2 pi. I got to find out my quarter points, which is, in this case, pi over 2, 3 pi over 2. Since it's cosine, it's going to start at 2. Follows this pattern. It's that simple. Now, what if I give you a different type of problem where period is different? So let's look at y equal sine of 3x. Before we graph that, I'll give you a couple seconds to catch up. So amplitude in this case is just 1. Period, in this case, omega is 3, so therefore the period is going to be 2 pi over omega. And omega is 3. So the hardest part is finding all the critical points. So it goes 0 to 2 pi over 3. How do I find the halfway between 0 to 2 pi over 3? You add 2 pi over 3 to the starting point, then you divide it by 0. And that will give you 2 pi over 6 or pi over 3. Again, how do you find all the other points? You add 0 pi over 3 to 0, then divide it by 2, and you get pi over 6. And after that, it gets super easy. So since you know every quadrant is pi over 6, this is pi over 6, you go over here 2 pi over 6, then this is what? 3 pi over 6, or pi over 2. Maximum is going to be 1. So you start at 0, go to 1, 0, negative 1, 0. Voila, done. Now let's do the next set. Now let me make the problem a little bit interesting. -4 cosine of 2x. Go ahead and look at that. What's the amplitude in this one? -4. Absolute value of negative over 4. What about the period? Period where omega is 2, so 2 pi over 2 gives you pi. So let's start 0 to pi. Boom. 1, 2, 3, 4. 1, 2, 3, 4. So the first midpoint, 0 to pi, is going to be pi over 2. The quarter is going to be pi over 4. This one is going to be 3 pi over 4. That's easy so far. Now the tricky part is, do you see this negative right over there? Cosine usually starts at the top. Because it's negative, it's going to start at the bottom, then goes to 0, then goes back up top, goes to 0, goes down. And that's how you graph. Okay, so we're gonna do some more crazy graphing later on. So this is the basic graphing right now. This is where I'll stop. If you have a question, email me, or you could call me in my office. I'll see you guys on Thursday.